Now we go to next annuity, which is N-year temporary life annuity. So the definition is a payment of RM1 per year payable continuously while X survive during the N years after issue. And then it happens that the X dies at X plus T. So the payment will stop here. So the Y is equal to AT because the time of death is in between N years, 0 to N years. So the payment will be made until T years. However, for the second case, after N years, X dies. So N years is here. So the death happened after N years. So the annuity will be paid until N years because it's temporary. We use variable Z for life insurance, and for annuity we use Y. So if time of death happen between 0 and N, so the annuity will be paid until T years. If the death happen after the N years, so the annuity will be paid until N years. So the expected value of Y is, this is stand for the VT, so for the interest, and this is for the PDF, TPX mu X plus T. Since we have two conditions here, 1 and 2, so we have two integration also here. So this case for the first one, 0 to N. And this case if the death happen after N years, so N to infinity. Then we simplify this integration. So mu X plus T also can be written in terms of TPX. So negative differentiation of TPX over TPX. So we cover in chapter 1. Then we cancel out the dt and we get this one. And for this one, since it survives more than N years, so what we left here is NPX. Then we do the integration by parts, UV minus VDU, and then we cancel out both here, and finally we get the annuity is 0 to N VT TPX dt for N year temporary life annuity. The difference between whole life annuity and N year temporary life annuity just the upper bound. So for whole life 0 to infinity, and for this N year temporary life annuity from 0 to N. So the component inside still same, VTTPX. So this is for case 1 and case 2. So this is for death happen between 0 and N, and this is for if the death happen greater than N. So as I recall, Z is for a life insurance. So this case is for endowment because we have two kinds of benefit. We have the benefit for death if death happen between n years, and we also have the benefit if the death happen after n years, so Vn. So we assume that the benefit is 1 ringgit. Okay, so this is endowment insurance. The expected value is AXN. So we already covered in last chapter. So how to find the variance? So this is the value for the variance. So from the expected value of insurance, we also can get the annuity using this formula. So annuity for temporary n-year temporary life annuity is equal to 1 minus endowment insurance for n years over delta. Same as whole life. So whole life annuity, it is using whole life insurance. So this is for whole life insurance and this is for endowment. Then for variance, we also can use endowment with delta squared. So as a conclusion, this is how we find the n-year temporary life annuity using endowment. And second one, if we want to find the variance. So now we try example 2. Find annuity with x equal to 20 and n equal to 10 if mortality follows first De Morph's law with omega equal to 60 and delta equal to 0.05. So then we can use this formula to find the annuity. First, we find the endowment insurance. So the endowment insurance, we have two components. This is for the death happen between n years, and this is for the benefit if the death happen after n years. So we have death benefit and survival benefit. So for De Morph's law, as I recall, the Vt is E negative delta t, and Tpx mu x plus t is equal to 1 over omega minus x. And to find the npx, or we can also use tpx, t and n just the variable. So for De Morph's law, the tpx is equal to omega minus x minus t over omega minus x using the sx. So we covered already in chapter 1. Then we can substitute the values inside. So the delta is equal to 0.05 and the tpx mu x plus t is equal to 1 over 40. So now we find 10p20. So 10p20 is equal to 3 over 4. So then we substitute here. And then we got 0.6516. Then we can substitute in annuity formula and we get for the annuity is equal to 6.968. Okay, second method for constant force. with mu equal to delta equal to 0.06. So both mu and delta has equal value. So the Vt is still same as the De Moivre's law, E negative delta T. It is force of interest. And then the Tpx is E negative mu T. So since the mu is constant, so mu x plus T is equal to mu. So this is for Vt, this is for Tpx, this is for mu. And same as De Moivre's law, this is the endowment insurance, so we have two components for the death benefit where the death happen between n years, or the death happen after n years. So we have Vn and Px here. Then we substitute the values. So Vn is negative delta T. So T is equal to 10. And then 10p20 is E negative mu T. So mu is 0.06, T is 10. So this is for delta, this is for T. And we solve for the integration, and then we get 0.6506. So for the endowment life insurance. Then we can substitute in the annuities formula, and we get the annuity is equal to 5.8234. Now we go to next annuity, which is M deferred whole life annuity. Same as the case for life insurance. So M is the deferred years. So M. So the annuity will be paid after M years. So that's why the lower bound is starting from M to infinity, because this is whole life annuity. The M deferred annual temporary life annuity. Still, the annuity will be paid start from M years and then until n years only, because it is temporary. So the upper bound is M plus n. So we also can find the M deferred annual temporary life annuity using this formula. So for the M deferred annual temporary life annuity also can be write down in terms of this one. So meaning that this one is this individual must survive until M years and times the annuity at X plus M for n years.